Hello everyone, my name is Alvaro, and in this video I will be solving another problem from the blind Leetcode 75 problem list. Today I will be doing problem number 3, which is called longest substring without repeating characters. This is a problem that I've been asked in one of my internship interviews. One of them was for Uber, and yeah, they asked me this question and later I ended up getting the offer even though I didn't accept it, but definitely something that you can find in an interview for a top company, at least in internships. So yeah, let's get to read the problem statement and let's get to solve the question. So the problem statement says, given a string s, find the length of the longest substring without repeating characters. So example 1 right here starts with an input s, and we have this string right here. And the output is 3 because the answer of the longest substring without repeating characters is ABC. It could also be BCA or CAB. Here, the answer will be 1 because it's one of the B's. And here will be WKE or KEW. So the output is 3. So yeah, pretty straightforward answers. So if you want to take some time to think about how to implement the solution, now will be the time to pause the video because I'm going to explain what approach we're going to take. So yeah, let's go with it. So, the problem statement says, right, the main idea is to find the length of the longest substring. And how do we do that? Well, we are going to use something called a sliding window approach, in which we are going to use 2 pointers, one that is always on the left of the 2 and one that is always on the right of the 2. And the main idea is to use this sort of concept of a sliding window. So for example, the first window will be this and the second one will be this. And if we encounter a letter that's not in our current substring, then we store it in our current substring or whatever we use to represent that, and we keep expanding. Right? So this would be our sliding window right now. And whenever we encounter a letter that is like this, that is already in the current substring, then what we have to do is we have to make the window smaller by making it 1 space smaller on the left. And this process will be repeated until the substring does not contain any repeated characters, which would be here. And then we would go like this. And after that, B is in the substring. So now we make the sliding window smaller. And now we have CAB. Now we check CABC, and C is in the substring. So we make it 1 smaller, and so on and so on. Now, what we are going to use to represent the letters in the substring, I think a set would be a good idea. Because if we use the substring, right, it would take O of M time, where M is the length of the substring, to find whether the letter is there or not. And if we use a set and we just keep storing and removing letters in the set, accessing those letters will take big O of 1 time, which is more efficient. So that will probably be a better idea. So let's start with this approach, right? So for example, in here we start with an A. We have to keep track of the length of the current substring that we're looking at and the maximum length that we've found so far. Whenever the length of the current substring is greater than the max length that we found before, then we have to update the max length with the length of the current substring. So here we would start with a set that has an A, and we would have a left pointer that points towards the A and a right pointer that points towards the B. And we will have to check if B is in the set, right? B would not be in the set because we have not encountered a B yet. So we add B to the set. We increase the right pointer by 1. So we move it to C. We update the current length of the substring to 2. And since 2 is greater than the one that we found so far, which is 1, then we increase it. And we keep repeating this and so on and so on. I think it'll be easier if I write it down, maybe to follow. So we have some things here. So we have the current length of the string. We'll always start at 1. And the max length will be 1. And then we have a set that would start with, we would just fill it with the first letter, right? So Actually, let me just do that. I think it's easier to read it this way. So we start with the left pointer here and the right pointer here. So what do? Well, we check whether the letter that B is that the right pointer is pointing to, if it's in the set. And if it's not, we add it to the set. We increase current length by 1. And if current length is greater than max length, then we update max length. And then we move the right pointer 1 space to the right. Is C in the set? No. So we do the same thing. We add C to the set. We increase current length by 1. And we compare current length to max length. And if current length is greater than max length, which in this case it is, we update max length. And then we move the pointer 1 place to the right. Is A in the set? Yes, it is. So what do we do now? Well, what we have to do is we have to remove the letter that the left pointer, important here, that the left pointer is pointing towards. In this case, it happens to be an A. And then we move the left pointer 1 space to the right. And then we decrease the current length by 1. Is A in the set? Once again, now it's not. So we update current length. And we move the pointer 1 space to the right. Is this B in the set? Yes, it is. So what do? We remove the letter that the left pointer is pointing towards, which happens to be a B. We decrease the length of current length, and we move this 1 space to the right. Is B in the set? No, it's not. So we add it, we update, and we move 1 space to the right. Is C in the set? Yes, it is. We decrease, we remove, we decrease, and then we move 1 space to the right. Is C in the set? No, it's not. So what do? We increase, we compare, no need to update here. We move 1 space to the right. Is B in the set? No. And this is why it's important to not remove simply like it happened in these cases, like A, B, or C, but rather whatever the left pointer is pointing towards. Because now, for example, we will have to remove whatever the left pointer points towards, which is an A. We decrease the current length. And now we move the left pointer 1 space to the right. And we keep the right pointer where it was. Is B in the set? Right? We check the right pointer. Yes, it is. So what do? We remove whatever is the left pointer is pointing towards. We decrease the current length, and then we move the left pointer 1 to the right. Is B in the set? No, it's not. So what do? We add it, and then we increase the current length. It's still smaller than max length, so we don't need to update it. We move 1 space to the right. It's B in the set. Yes, it is. So we remove, we decrease by 1, and then we move the left pointer 1 to the right. Sorry. Yeah, there you go. This should be a B, sorry. Is B, remember we're looking at the right pointer always. Is B in the set? Yes, it is. So what do? We remove, we decrease by 1, and now we move the left pointer 1 space to the right. So now both of them will be here. So I'll just put it right here. And now we look at the right pointer. Is B in the set? No, it's not. So what do? We increase, we add, we compare. It's not greater than max length, and then we move 1 space to the right. And this algorithm will end whenever the right pointer exceeds the string. So yeah, let's get to code it now. I hope this walkthrough was pretty clear. I think I did a good job with it. So yeah, if you still find it not very clear, try and replay that and maybe try with this string right here, example 3. I feel like that would be a good example. But let's get to code it right now. So one of the base cases here is that the string is empty, and if the string is empty, then we simply return 0. So if the length of the string is 0, then we return 0. And in any other case, we start with the left pointer pointing towards the first element, the right pointer pointing towards the second element, and then we can call it scene. This keeps track of the element of the letters that our current substring has. So scene is equal to a set with s sub 0. And now, while right pointer is less than the length of the string, because remember, this ends whenever the right pointer exceeds the length of the string, we're going to keep going. So we're going to do the first case, which is if the letter that we're looking at with the right pointer is not in the substring, then what do? Once again, we haven't defined current length and max length, and I think we should. There you go. So what do? We update current length by 1. We add the letter to the set so that it's now in our substring. We increase the right pointer by 1, and now we compare max length with current length, and if current length is greater, then we set max length equal to current length. The other case is that the letter that we're looking at with the right pointer is in the set. So what do then? Well, then what we have to do is first we have to remove the letter that the left pointer is pointing towards. We decrease current length by 1, and then we increase the left pointer by 1. So let's double check again. So if the right pointer is pointing towards what we've seen, right? Let's see. So for example, in here, and B, we have B, C, A, B. Then what do? We remove the B. We decrease the current length, and then we move the left pointer 1 place to the right. And what if, for example, we are in AB and we encounter a C? Well, if the right pointer is pointing towards the C, of course. So the right pointer is not in scene, so we update the current length, we add the C towards the set, move the pointer 1 place to the right, and then we compare the length with the max length, and if the current length is greater, then we set it equal to that. So this loop should cover all those operations, and at the end of the while loop, whenever we finish it, we simply return the max length. And that should be it. As usual, the runtimes are a bit inconsistent, but this is the main idea behind the solution. And yeah, so what would be the runtime complexity of this problem? So the runtime complexity of this problem is big O of n, because in the worst case scenario, we simply visit each letter in the graph twice. So that will be an example like B, B, B. So we move the right pointer 1 and the left pointer 1 and so on and so on. And 2 times n is still big O of n, so that will be the runtime. And what would the worst case scenario be for spacetime complexity? Well, the worst case scenario for that will be big O of n. It will be a string in which all the letters are different. So we will store every single letter. And yes, that will be the spacetime complexity of this solution. And yeah, that will be the end of this video. I hope you found it helpful. And make sure to hit like and subscribe and yada yada. And thank you very much for watching the video, and see you in the next one. Bye-bye.